Hello guys. So in these last few videos for this school year we are going to focus on solving equations, and today in particular we are going to talk about solving cubic equations. So we're going to do this by using the process of factoring. So as usual I will show you some example, and then I would like for you to try to work some related problems, and then I will assign also homework on Alex. Now, in reality, there is a formula you can use to solve a cubic equation. We know that there is a formula that you can always use for quadratic equations, and there is one for cubic, but in reality, nobody really uses it because it's a very long formula. So it's not too simple to just plug in some values there and find the solution. So that's one of the reasons why it is usually not well. Usually you won't find a teacher that is gonna teach you how to plug in numbers into the cubic formula and then find the solution from there. Instead, there are methods that sometimes you can use, and one of those methods is the one I'm going to show you today, which is factoring. Now keep in mind that factoring does not always work, while the cubic formula will always work, okay? Okay, so here we have example number one. So we have a 2x cubed plus 3x squared plus 8x plus 12. And then we're going to set up this equal to 0. So just a reminder, solving means find the values of x that are going to make the left hand side equal to 0. Alright, so in order to do this by factoring, what we're going to do is we're going to group the first two terms, and we're going to group also the last two terms. Okay, see if we find the common factor between those two. Alright, so if you look at the first two terms, we have a greatest common factor, which is x, well, x squared, right? Because there is an x squared, there is an x cubed, so we're going to factor out x squared. And then x squared times what is going to give me 2x cubed? Well, this is going to be 2x. And then x squared times what is going to give me 3x squared? This is going to be simply 3. Now let's look at the last two terms, and let's see what we find in common between these two terms. Notice that they are both divisible by 4. So we can factor out a 4, that's the greatest common factor. 4 times what is going to give me 8x, that should be 2x, and 4 times what is going to give me 12, that will be 3. Notice how we get the same amount in parentheses, which is 2x plus 3. Now you have seen this already, this process, because that's what we do when we solve a quadratic equation by factoring. Okay. So these two terms in parentheses are not the same, and then we cannot use this process. Okay. So we have 2x, unless we made a mistake, of course. So we have the same terms, which is 2x plus 3. Now this can be factored. We have 2x plus 3. And then what's left is x squared plus 4. Okay, and we need to set up this equal to 0. Alright, so how do we find the solution? Well, here we have the product of two terms. Let's say that the first term is a and the second term is b. So the product of these two terms, a times b, is equal to 0 when either a is equal to 0, right, because 0 times any other number is 0, or when b is equal to 0, because b, if it is 0, 0 times a is still 0, right? One of the two needs to be equal to 0. A is in this case 2x plus 3, so we're going to set up this equal to 0, right? So a equals 0, or b equals 0 means x squared plus 4 equal to 0. And then from here we need to solve two different equations. So let's focus on the first one. Well, if 2x plus 3 is equal to 0, then this means that 2x must be equal to negative 3, which implies, if you divide both sides by 2, that x is equal to negative 3 divided by 2. So here we have the first solution, which means if I plug in x equal negative 3 over 2, into the original equation, the left hand side is going to be equal to 0. We are not going to do this, but in case you want to check, you can plug it in and just verify that you get 0. Now the second one, how do we solve it? Well, that's a quadratic equation. X squared plus 4 equals 0. Notice that before I solve it, I can already conclude that I'm not going to find any real solution from here, because if you have the square of a number, you know, is always positive. If you add the 4 to this, you will never get 0, right? So it's impossible to get 0 in terms of real number. However, there are some imaginary solutions, okay? Remember that if we extend solution of an equation in terms of also complex number, we always are going to find the solution of a polynomial equations, okay? So if we have a polynomial integration of degree n, we're going to get n solutions for sure, okay? And this is in fact called the fundamental theorem of algebra, okay? So that's why we know we're going to get solution. However, these solutions are not going to be real, because again, if I square a positive number and I add 4, I will never get 0. So what are the solutions? Well, we can get x squared by itself. So we have x squared equal to -4. And now at this point, we can take the square root on both sides, and remember to place a plus and minus sign in front. And now recall that the square root of a negative number becomes I. So this is the same thing of plus and minus I, because the negative square root of -1 is I, and then we are left with the square root of +4. So the negative, okay, under square root becomes I. So plus minus I square root of 4, and then we know that that the square root of 4 is 2, so this becomes I times 2. You can also say plus and minus 2i is the same thing. You can interchange these two terms, okay? Alright, so let's write down the solution set here. So what's the solution set? We got 3 solutions because we have a cubic equation. So sometimes the solution may coincide. In this case, we have 3 distinct solutions. So one solution is real, which is -3 divided by 2, so it's a real number. And the other 2 solutions are imaginary solution. One is a -2i, and the other one is a +2i. So 3 total solutions, okay? Okay, so in example 2 now, I would like for you to work this problem, and then you check your understanding with me, okay? Alright, so here is the problem, number 2. We have 2x cubed minus x squared plus 2x minus 1 equals 0. So follow the same process I show you number 1 and see if you can find the solution on your own. Okay, so you should stop the video and try to work this problem, and then you will check with me. Okay, so you can do that now. Okay, so I assume you work this problem. Let's see how to find the solutions. Well, if I use the same strategy that I show you number 1, we're going to underline once the first 2 terms and twice the last 2, and we look for greatest common factors. What's the greatest common factor between 2x cubed and -x squared? Well, that would be x squared. Then we open parentheses. X squared times what to give me 2x cubed? That will be 2x. And x squared times what to give me -x squared? That will be -1. And then if you look at the last 2, there is a greatest common factor, which is 2x minus 1. And well, the greatest common factor is just 1, right? So we have 1 times 2x minus 1, and then we have equal to 0. Notice how again these 2 terms must be the same. So now we can factor out the 2x minus 1, which means we write this only once. And then this is going to multiply whatever is left outside the parentheses, which is x squared plus 1. And we set up this equal to 0. Again, we have the product of 2 terms. Say this is A, and say that this is B. And the product of 2 terms is equal to 0 when either A is equal to 0, which means 2x minus 1 equals 0, or B equals 0, which implies x squared plus 1 equal to 0. So solving the first one is very simple, just add 1 and divide by 2. So we get 2x equal 1, which means x equal to 1/2. For the second one, again, like in problem number 1, we are not going to see any real solution because x squared is positive. I'm adding a positive number, so I cannot get 0 with a real number. It must have imaginary solutions. In fact, you see this by subtracting 1 from both sides and just taking the square root and put a plus and minus in front. And we know square root of negative 1 is I, so from here we get x equal to plus and minus I. Okay? So, we have one real solution again and two imaginary solutions. So the solutions set is given by 1/2, which is the only real number, and then we have a negative I, and then we have a positive I. Okay? Alright. Let's work some other examples. Okay, so let's go with problem number 3. Okay, so here we are with 3x cubed minus 6x squared plus 2x minus 4. And we're going to set up this equal to 0. Okay, so based on the, again, you should try this by yourself first, okay? And then once you work it, just check with me. So let's underline the first two terms once, the last two terms twice. Let's look for greatest common factor. So if I look at the first two, there is a 3x squared in common. And then here we have a 3x squared times what to give me 3x cubed is just x, and 3x squared times what to give me negative 6x squared will be a negative 2. And then if you look at the last two, there is a 2, which is a greatest common factor, and then 2 times what to give me 2x will be x, and 2 times what to give me negative 4 will be negative 2 equal to 0. Again, these two terms are the same, so we can factor them out. Well, we can factor this, which is x minus 2. And then what's left of the parentheses is 3x squared plus 2 equals 0. So the product is equal to 0 when either x minus 2 is equal to 0, or when 3x squared plus 2 is equal to 0. And then this implies for the first one that x must be equal to 2. The second one, you should see merely we have an imaginary solution because we are adding two positive numbers and the sum cannot be 0. And the way we solve it is by subtracting 2 from both sides, dividing both sides by 3 to get x squared by itself. So we have x squared equal to negative 2/3, and then to go from x squared to x we take the square root, we put a plus and minus in front. Now remember that the negative sign inside the square root becomes I, so we are left with x equal to plus and minus I, square root of 2 divided by 3. Okay, because the negative sign is I, square root of negative 1 is I. So what's the solution set? Alright, so this will be equal to 2 negative I square root of 2/3 and positive I square root of 2/3. So again, two imaginary solutions, one real solutions. Okay? Okay, let me give you another problem. This is so let me write it down. We have 3x cubed plus 5x squared minus 3x minus 5. Okay, so again try to do this by yourself, okay? And then check with me. Okay, I will work this a little bit faster. At this point you should already be familiar with this type of problem. So, first two terms, we have greatest common factor, which is just x squared. So inside parentheses, we're going to be left with 3x, and then we have a plus 5, and then if you look at the last two terms, the greatest common factor is negative 1. So we have negative 1 times 3x plus 5, and then we set up this equal to 0. So now we have a greatest common factor, which is 3x plus 5. And and then this is going to multiply x squared minus 1 equal to 0. So here we have the product of two terms equals 0, when either 3x plus 5 is equal to 0, and when x squared minus 1 is equal to 0. So if we solve the first one, we get, well, you subtract 5, you divide by 3, so x equal negative 5 divided by 3. And then for the second one, you add the 1 on both sides, we get x squared equal to 1. And notice how in this case we have two real solutions, because we don't have we don't have any negative on the right hand side. So if we take the square root from here, we will put a plus and minus, we just get x equal plus and minus 1. So we have three real solutions. So the solution set is negative 5 over 3, and then negative 1 and positive 1. Okay? Alright, so at this point what I'm going to do is I'm going to assign you a few other problems. I'll give you the solutions. If for any reason you still have a difficulty with this, please attend the tutorial, okay? Tutorial should be on Thursday, but please check updates on Schoology and make sure that you know which day is tutorial, okay? Because it may change sometime. Okay, so the next problem I'm going to assign you are this one is 3x squared, so plus 2x squared minus 12x minus 8, minus 8 equals 0, so try to work this by yourself, and then I'm going to write the solution here so you can check. Just see one moment. Then now I'm going to put the number 7 here because this is what I have on the paper, so I remember which solution to give you, okay? Then in my paper I have problem number 11, which I can give you the solution. So here the problem is 4x cubed plus x squared minus 8x minus 2 equal to 0. And then I'm going to give you problem number 15 to work, whose equation is 5x cubed plus 15x squared plus 4x plus 12 equal to 0. And then last one is number 19, whose equation is 3x cubed minus 2x squared minus 6x plus 4 equal to 0. Now, let me give you the solution. So for problem number 7, you should get negative 2/3 and then negative 2 and positive 2. For problem number 11, the solutions are negative 1/4, square root of 2 and negative square root of 2. For problem number 15, we have a negative 3, and then we have imaginary solution are 2i square root of 5 divided by 5, and then negative 2i square root of 5 divided by 5. Notice how the imaginary solution comes always in pairs. And then the solution for number 19 are 2/3 and then square root of 2 and negative square root of 2. Now in something like problem number 15, the solution you may find it can also be written as negative 3 2i divided by square root of 5 and negative 2i divided by square root of 5. The solutions are the same of 2i square root of 5 over 5, because if you rationalize, which means you multiply and divide numerator and denominator by square root of 5, you get square root of 5 over 5, because 1 over square root of 5 is the same thing, so same of square root of 5 divided by 5. Why? Because if you have 1 over square root of 5 and you multiply and divide by square root of 5, so you multiply by 1 practically, so you have the same expression. The numerator becomes square root of 5 times 1, which is square root of 5, and the denominator becomes square root of 5 times square root of 5, which is square root of 25, equal to 5. So please understand that the two solutions, the two sets of solutions are the same. Okay. Alright, so let me know if you have any question, and you can practice a little bit on this, and then make sure you also work the Alex assignment.